Okay, so our first talk is turning an NFT into a metaverse object in 10 minutes. So this is, so I'd like to invite Paul Thomas.
All right. Can people hear me, or do I need that one? I'll have this. I normally walk around. Hi, everyone. My name is Paul. So I'm representing a project called Somnia. You probably haven't heard of us because we're new in the space. We're actually still in stealth mode right now. And today I'm going to be talking you through how we turn NFTs and turn them into metaversal objects in 10 minutes. It's a little bit clickbait. Sorry about that. So what we're doing at Somnia is basically building an interoperability layer for the metaverse. So we're trying to do two things. So the first thing is building up a blockchain that enables very high throughput transactions on top of the EVM. That's what I wanted to talk about today, but unfortunately, because we're in stealth mode, that's still very secret, so I can't talk about that. So the other thing we're doing is a protocol. So this protocol enables you to put all the people, places, and things of the metaverse on-chain, as well as their associated logic, making them interoperable. And today we're going to talk through part of that protocol, specifically the object protocol. So first, before I do that, I want to lay out the problem and explain what we're doing a little bit more. So the key problem is NFTs aren't really usable across 3D virtual experiences. If you think about NFTs today, they're pretty good at representing static pieces of art, JPEG, and if you think about using them within digital experiences, you can tend to use them in one, maybe two experiences. If you think about like a sandbox, you can buy an NFT there, use it in sandbox. You can't really use it elsewhere. So what we're trying to do is turn these NFTs into objects that can be used across multiple different spaces in the digital world, basically moving them from ownership records to actually digital assets. So what if you could do that? How could you go about doing that? That's the kind of question we're posing. So in order to do that, you kind of do three things. The first thing is you need to be able to define the object. So you need a new language to make that object interoperable and usable across many different spaces. The next thing is you need to extend existing NFTs. So there's a bunch of immutable NFTs that live on chain today. You need a way to take that data and extend it with this interoperable definition language. The final thing is you need a bunch of cool experiences you can use them across, so they're actually useful, valuable, and fun to use. So these are the three things I'm going to go through today. So the first thing is the language. So we've created a new language called Metaverse Markup Language, or MML. So you'll notice that sounds very similar to HTML. It's because it's very much inspired by HTML. If you look here, there's a bit of the scripting code. Looks very similar to HTML. If you've done any web programming before, you'll be able to pick this up pretty quickly. So the difference is HTML is designed for 2D web pages. This is designed for interactive 3D objects. So here we have a bit of code, and this is what we're going to be building today. We're going to be building a metaversal dice, so a dice we can use across many different spaces. So the code over here, I'll just walk through this quickly. We have the M model tag. This is kind of the most primitive tag, which says this is a model. We then give it an ID. So this ID, if you've ever programmed with JavaScript before, HTML, you'll know you give your tags IDs, and then you reference them later. So we give this tag an ID with dice, so we can reference it later in code. We then have a source file. So this is the 3D asset that will be associated with this object. They'll be used across the different spaces. And finally, there's a bunch of subtags that give it collisions, opacity, X, Y coordinates, all the kind of stuff you would think of. I'm not going to go into those detail today. There's a bunch of other subtags you can have as well. So that's MML, and now we've defined our dice. So what I would normally do at this point is start a live demo, have my laptop here, but we can't do that today, so I've prepared a bunch of videos, so hopefully you can see what's going on. So the first thing we do is go to mmleditor.com. So this is our inbuilt web browser-based editor. The reason we've gone for this approach is that it means that anyone can collaborate. So you can just go to this link, start playing around, start using it today. You can also obviously do this in all your kind of normal IDEs and tools that you'd expect. So we go to mml.com and we start up our project. Go to projects, load that up, load up one of the projects we've loaded earlier, paste in our code, and then we have our dice. So just to talk this through a little bit, if you've ever done any kind of game development, this will kind of look familiar. On the left here, we have all the different assets. In this window over here, we have the edit window. So this allows you to edit your object, move it around, change it. Here we have the play window. So this will look like in a game engine or in a real life experience. Here we have the code window to write some code. And here we have the inspector to change different properties. So you see we've got our code here with our dice. We've also got a couple of other attributes here. We've got an on-click event, similar to what you'd see in JavaScript when you have an on-click event, and an X and a Y coordinate. So we've got our dice, which is kind of cool. Next, we're going to start manipulating it. So here, we have the dice in our editor, and we start moving it around. And you see it moves live as we're playing the experience. So this is cool because you can start to be in the same space, collaborating, seeing it. So now what we're going to do is bring up 2 other browser tabs and have that same dice there. So you can kind of think about these as experiences within themselves that are sandbox, and the dice is both in those places at the same time. And as I move it in the editor window, it moves here, and it moves here, and it moves here. So what we have is a live editing experience that allows you to quickly build up these objects, play around with them, and experience them quickly. So what I'd normally do at this point is share that link with everyone, and then you'd be on your mobile phones and have the dice on your phone. Can't do that because we've not got a live demo today. So we go to the next slide, and now we're going to add some code to it. So here we add some simple JavaScript, which basically allows us to spin the dice whenever we click it. So when we click the dice, it starts spinning. But you see here it's also spinning when I click it, and you see here it's also spinning when I click it. So this is really interesting because what we've done is written one piece of MML with a little bit of JavaScript, but we now have a networked object that exists across many different spaces simultaneously. You didn't have to write any networking code. You just have to write some JavaScript and a little bit of MML. And now we have a multiplayer dice that we can all interact with and play with across web browsers. So that's pretty cool. It's pretty useful. The next thing now is taking that into a richer 3D experience. So this is using M squared, which is this engine that allows you to have thousands of people in the same space at the same time. Here we're logging into the test metaverse on top of M squared, which is basically a place you can go to today. It's called Construct. If you go to construct.io, you can start playing around with this. So this is a much richer environment built on top of Unreal. You can see it has shadows, it has cool graphics. We go up to this pedestal here, and we spawn in our same dice. So here's our dice. It's looking a bit shinier now, has a nice shadow as well, but it still has that same click logic where I click it and it rotates. Now if I go out of here and go into the browser editors from before, you see it's also moving here. So again, all the data is being synchronized between all these different spaces. All I had to do was write a little bit of JavaScript to do that. And now I have it actionable in a rich 3D world as well as a 2D web browser world. So hopefully you're kind of getting the point here. You have this language with a little bit of JavaScript that allows you to define an object and use it in many different places. So I've shown you the web editor. I've shown you M squared, which is this richer 3D world. There's also a world that we're going to be releasing called the Playground, which is a 3GS-based world, which basically allows you to create objects, will be fully open source, and anyone can start using it, bringing people into those experiences and bringing those objects in. So now I want to show a slightly more rich object, an interactive object. So this is a fully fledged Game Boy, which we're going to build in MML. Now I'm not going to go through this because we'd be here for the next hour, but essentially this has a lot more stuff to it. It has a lot of buttons, has a lot of code, it calls out to an external third-party web service. So there's a lot more going on here, and it's a lot more rich and interactive. But we can have the same thing of the Game Boy being played in the web browser, so this is Pokemon Red, and we have the same Game Boy being played in the rich 3D world. But you see it's fully synchronized. So now we've basically made a massively multiplayer version of Pokemon, all with that little bit of code that you saw before. This is kind of similar to if you ever saw Twitch plays Pokemon, but rather than people typing in a text chat, you can actually touch this Game Boy, play it, and use it in the real world. So again, you're seeing much more rich interactive objects now. So now let's take this into Decentraland. So this is a fork of the Decentraland client. We go into a little square, and once this loads, so here, people will recognize this. This is Decentraland, and here's that same Game Boy again. So really you're seeing now these rich interactive objects being used across many different spaces where you just define it once, define the code once, and use across these many spaces. So hopefully you're getting the point now, and you kind of believe that MML is a good language to do this. So the next problem is how do you extend existing NFTs with this? So obviously if you were creating an NFT from scratch, you could just add the MML reference to your metadata, and you'd be done. But there's a bunch of immutable NFTs that exist on chain today, and we thought we needed a way to extend them. So the way we do that is with an object registry. So this basically is an on-chain contract that stores a mapping between the NFT record, which is just an address, and a hash of the MML document, which will live in some kind of storage, like IPFS or our own storage solution. So just to kind of reiterate how this works, you have the object registry, which is a contract that lives on chain. That has a pointer that points to an NFT as a token of record. These all live on blockchains. That object registry also has a hash and a map towards an MML document, which will live on some storage elsewhere. That MML document itself will reference all the 3D assets and graphics and associated things with that object. So hopefully now you're seeing how you can take an existing NFT and extend it with the object registry. So here's a little demo of us using that. So obviously you can poke the smart contracts directly if you want to. This is obviously also very early. Again, we're currently in stealth mode, but hopefully it kind of demonstrates the point. So what I'm going to do here is upload the MML, which is the DICE MML that we had before. I'm then going to upload the 3D files, so the GLBs. Give my object a name. I'm going to call it DICE. Associate it with a contract. So go to my wallet, find an NFT, get that contract address, put that in there. Set permissions. I'm not going to go into this now, but essentially you can set permissions for where the object can and can't go. So you can say it can't go to these metaverses, it can go to these experiences. Here we have that object within our kind of wallet. And here we're logging into the playground that I talked about before, where we're going to spawn in that dice based on the fact that I have that NFT in my wallet. So I go into the playground, wait for this to load, and we have our Metaversal dice again. So what this engine has done is basically looked at my wallet, seen that I own this NFT, looked that up in the object registry contract, streamed in the MML object, and put it into the scene here. So now you can start to see how, based on the NFTs you own, you can start spawning in these digital objects and start populating a space based on that ownership. But the real cool thing that we think this will be used for is creating avatars. So taking PFP projects, turning them into interoperable objects, and allowing you to equip that as a person. So that's what I'm going to show you next, how to create one of those interoperable avatars. So here we have the code to create what we call a single mesh avatar. So all it is an M character tag with a source 3D asset file, which will have all the 3D assets and animations. And that creates a single mesh avatar. So we have a little demo of this where you can upload a Minecraft skin and turn that into a 3D avatar. And this is pretty cool and pretty useful. And then you could do that NFT association and be able to spawn that in. You can also have this as an AI in an experience, kind of roaming around with a logic if you wanted to. So this is useful, but if you think about a PFP project, it could have 10,000 different variations, which means you have to make 10,000 meshes. It's going to take you absolutely ages. So we've created a way to modularize this, where you can create just the individual components and have them reassembled based on the traits of a PFP. So here we have the modular version of this. We have the same M character tag. Now we have a head and a body component, which then can be recomposed. So instead of making hundreds of different meshes, I can just make 20 different heads, 20 different bodies, and recompose those modularly. So an example of someone that's done this is a guy in the M-Squared community called Directed Creator. So he has this project called Grills Gang, which are these cool looking teeth. So this has a bunch of traits like any PFP project. It has the eyes, it has the top teeth, the bottom teeth, the key, the shoes, all those different traits and all those different properties. And what he does is basically create 3D assets just for those different properties and then programmatically constructs the MML avatar based on those different properties, which is just pointing at the 3D objects. So taking the NFT traits, turning them into different components, and turning that into an avatar programmatically at runtime. So here we have a video of another project we've done this with, which is Forgotten Runes. So Forgotten Runes is kind of like a wizard-based collection, is the way I put it. So what you're seeing here is all of the Forgotten Runes characters imported into a 3D space. But the really cool thing about this is that there are 10,000 avatars in the same space at the same time. All are individual, all can communicate with each other, all can be with each other. So this is using that M-squared technology that I talked about before, and hopefully is kind of getting towards what you can kind of do with the whole tech stack. You can start to now have whole communities of thousands of people in the same space, all being fully customized with their NFT avatars. So another example of an experience which you could use these in is this experience here. So this is an experience we did with Major League Baseball. This wasn't supporting MML at this point and the NFT integration, but will do in the future. Here you had people, I think around 8,000 people turned up to watch a baseball game. They had these like little collectathons, they had these little quizzes. They then went into the baseball stadium and watched a baseball match. But you can imagine if this had the integration with the NFT stuff that I showed before, these could all be individualized NFTs, characters that people have purchased, people own. You could also start to spawn in objects based on their ownership, really integrating kind of blockchain ownership into a digital experience. The really cool thing about this experience, when we go forward a little bit, is these kind of 3D characters that you see representing the players. This is actually a one-to-one digital twin of what was happening in the baseball stadium live. So what we did was stream data from the baseball stadium, and here you see this side by side, turn that into the 3D avatars in real time, and actually have a one-to-one replication. So the people could watch the baseball game as if they were there. And again, if you then add the NFTs on top, you're now adding that into the whole stack. So this is another experience. This video is a bit poor, sorry about that, because I cut this together. This is the experience we did with the Forgotten Runes project. It was essentially a mini game where they basically went through an obstacle course, and at the end, the winner of that obstacle course won a prize. This is the end of it, where they meet this big devil. I'm not sure what he's doing, but so essentially, what you're seeing here is a community come together and have kind of an activation which is really cool and quite novel and different to what they would normally do together. Normally you just hang out on Discord, hang out on Twitter Spaces. Now you can have these rich 3D interactive experiences all using your avatars and collections. So the final thing I want to show was this working with Apple Vision Pro and spatial compute. So this is one of our engineers at home with Apple Vision Pro. And what you're going to see here is 4 MML objects spawned into the space based on NFT ownerships. These are 4 different objects based on what he owns. And so this is obviously just a tech demo. But if you imagine a future where you can start painting your room and your real life experience based on your ownership records. So you can say, I'm gonna put a piece of art on the wall here, or I'm gonna make a little interactive experience on my table here, which other people can play with, or maybe something in my kitchen. So you can start painting the digital world onto the physical world. And then in a future where we're all kind of wearing these glasses, you're now seeing the mixture of digital realities and physical realities, which I think is really what the future of all this stuff is. You have these rich 3D experiences bridging into the real world. So thanks very much for listening. Again, it wasn't like probably a normal Web3 talk where we went deep into Web3 stuff, but we had a few things here today. 1, we showed you a new language to define interoperable 3D assets through MML. 2, we showed you how you can link that to existing NFTs and extend existing NFTs that live on chain. And 3, we showed you a bunch of different experiences this can be used across, be that a baseball game, be that Decentraland, or be that in the real world of Apple Vision Pro. Thanks very much for listening. If you're interested in starting building and get started, you can go to this link over here. That's mml.io. You can start building with this stuff today. If you want to just stay tuned, you can go here. That will link you to our Twitter. Again, as I said, we're currently in stealth mode. We haven't released much of our Web3 stuff yet, but it'll be coming out starting April and we'll be starting to talk about the project a lot more publicly. Thanks very much, and any questions?
Thank you very much, Paul. Any questions for Paul? Oh, go on.
Okay, very interesting. Quick one. This is more like a philosophical question. So I'm into indie games and small games that have some sort of uniqueness about them, that are artistic. So my question is, if you have an object, let's say it's an apple, that object is not going to render correctly in a pixel art game, for example. Likewise, if I want to play a game like Head Cups, which is like a vintage game, my apple is going to look full of colors. It should look black and white. So if you allow this, then people will destroy the aesthetics of that game, because that game has a rule, like all the objects need to be black and white and need to look like vintage, 70s. So how do you solve that problem?
Yeah, so there's 2 things here. So I think the first thing is you don't solve that problem. Games are quite special in nature, and they're pieces of art. And I think having interoperable games, which I think a lot of people in the Web3 space, I don't think that works in reality. If you imagine Harry Potter, and I can bring in AK-47 to Harry Potter world, that's a bit of a weird game, right? So I think this for games isn't really the point. What I've showed here is a lot of social style experiences where I think really interoperability can be true. And I think taking things from those game worlds into those more social experiences can work. But I totally agree with you, bringing them into those game worlds, that's probably not going to work, because these are pieces of art that aren't designed to be interoperable.
So it's not going to work on indie games and artistic games.
So, but the other part to that is, so there is a pipeline behind this that I didn't really go through today, where you can take the 3D version, turn that into a 2D pixel version, turn that into a monochrome version. So you have different art styles that are available for people, so they can pull dependent on the artistic direction of their experience and of their world.
Okay.
So with a 2D indie game, I could imagine that there's a 2D pixel art version of the interoperable object and a 3D version that can be used across the 3D experiences. And that I can imagine working. But I do agree with you in terms of the kind of premise of games. Games are pieces of art. Allowing anything to come into your game, it's not really a thing that I would advise and think makes sense.
Thank you.
Any more questions? Paul, I have a question for you. When we're talking about when you were talking about the synchronization of all of the different characters, all the NFTs, can you go into any detail at all, or is this?
No, I can go into a little bit of detail about that. So there are 2 major problems to solve that. One is the renderer. So how we're doing the rendering there is essentially a machine learning algorithm which learns how to compress data on the rendering side, and then a lot of aggressive what's called LODing. So based on how far away you are from the camera, you'll see if you actually look into the far distance, those characters were much more pixelated than the ones that are closer to you. The other side is then the networking. So that again is a machine learned algorithm which basically compresses network data, allows you to go from what would be tens of gigabits down to like megabytes, sometimes kilobytes, depending on the data set. So that's essentially the way at a high level. Hopefully that makes sense.
Excellent. Thank you very much. Any more questions? All good. Paul, thank you so much. Really
Cheers, thanks a
appreciate
lot.
your talk.